find out if they contradict Mary's belief. So a person contradicts Mary's belief if one of the following statements is true, if they are young and beautiful but not loved, or if they are loved but not young or not beautiful. Okay, so let's do this one, I guess, as literally as possible to begin with. So let's just say, let's just put these word sentences into programming. So into lines of code. So, okay, if they're young and beautiful but not loved. Okay, so let's try that. Young and beautiful but not loved. So that means and not loved. Okay, so that's one situation. That would represent a contradiction for us. Or the other situation is if they're loved but not young or not beautiful. Okay, so let's try that. Loved, that part's true, and, whoops, not young, or not beautiful. Okay, so are those the cases we're looking for? Let's run this. Okay, cool, that seems like it's working. But you know what? I think I want to alter the content here. It feels a little shallow to be talking about this all young and beautiful stuff. So let's say weird and nice. Let's go with that. So we've got weird instead of young, and we've got nice instead of beautiful. Okay, whoops, slippery. All right, so is that good? Is that working? Yeah, and it's passing all the hidden tests. Okay, cool, cool. So that's good, but maybe there's a way we could sort of alter this one in a bit. So here, let's make another copy here. We'll say this is going to be willYou 1. Okay, and what are we going to do with this? Well, we're going to apply some principles of logic here. So this is kind of cool. If we've got a situation, oh, and there's a name for this rule. Okay, if you're in the chat right now, or if you're watching this on YouTube and you want to leave a comment, someone tell me the name of this rule, okay? Because this is like a popular rule of like logic and set theory, and I don't remember exactly what it's called, but basically it's like this. Here, let me grab a sick color. Okay, so if we've got like A and B, yeah, okay, so we've got like A and B are booleans, we'll say here. So if we've got A or B, that's the cup symbol, right, for or. And we want to say, actually I should have started this differently. Let me clear that for a sec. Let's say we've got A and B. Oh, maybe I should have just used the like JavaScript notation. I'll do that in a sec. And we want to say not this. Well, let's think about this. This is going to be equal to, let's think about it. So we want to say not A and B. If you're not weird and nice, then that must mean either you're not weird or you're not nice, right? So that is the same as not A, okay, and I'll just, for emphasis, put that in parentheses, or not B. Okay, so yeah, not A and B is the same as not A or not B. So this is kind of like a distributive property almost, except what we notice is that we have to switch the symbol. It was an and here, it's an or here. So let me put that into more familiar terms, I guess. So what I'm trying to say is not A and B is the same as not A or not B. Okay, why is that relevant? Well, if you think about it, that's what we have here. Not weird or not nice. So my claim is that that should be the same as not weird and nice. There we go. Okay, so let's put that to the test. Is that going to work? Yeah, it works. Okay, so basically, what's the advantage here? Well, I'll show you. Check it out. Let's say that we want to define cool as being the combination of weird and nice. If you're weird and nice, you're cool. So now we can take this weird and nice thing over here, replace that with cool. And not weird and nice would just mean not cool. Is that going to work? And yeah, it does. Passes the hiddens? It passes the hiddens. Okay, cool. So that's good. That's working nicely. But could it be nicer than that, I wonder? Well, let's think about it, because there's something we might be noticing here. So if we're looking at this one, we see, and let me just go back to the description for a sec. Okay, so we basically see something interesting. I guess I can reference this. Cool and not loved, or loved and not cool. Okay, so that's kind of interesting because that's, well, sort of familiar. It's actually kind of relevant to something we were talking about, I think, just yesterday in one of the previous challenges. So we'll use a different color for this part. Here's what we want to say. So we've got A, B, and then what we want will be over here. We don't know what it is yet, but basically A could be false, or it could be true. B could also be false, or it could be true. And we're just going to use zeros and ones to represent that. So just putting all the logic together here, basically, let's say this is cool, this is loved. So cool and not loved, or loved and not cool. Basically, one of them needs to be true, the other needs to be false. So if they're both false, we'll get a big old zero there. If they're both true, we'll also get a big old zero. It needs for them to be one true and one false. So it's only in these middle situations that we'll get our ones here. So if you think about it, this is actually really similar to something we've seen before. Yeah, I'm pretty sure just yesterday we were doing this. This is A XOR B, okay? XOR, exclusive OR. XOR. So either A or B, but not both. That's what we're saying. X for exclusive, XOR. Okay, so that's what we want. XOR, A XOR B. Now, we were looking at bitwise operators last time, and we found that there's a bitwise XOR. And look at that, that's kind of familiar. But we don't have really like a logical XOR. You know, we don't have like a symbol like this is what I'm trying to say for XOR. You know, we've got the double pipe for OR, we've got the double ampersand for AND. We don't really have one for XOR. So we're going to have to handle this on our own. One way we could handle it is basically, let's make this really, we'll try to make it as straightforward as possible. So we'll say, all right, well, we'll use a ternary. So is it cool? Are you cool? If you're cool, then we should return true if weird, if loved is false, right? Because we don't want to be cool and loved. We want exactly one of them to be true. So if cool is true, then we want loved to be false. If cool is false, then we want loved to be true. Okay, so does that make sense? Let's find out. Yeah, it makes sense. All right, at least it makes sense to the interpreter here. Hopefully it makes sense to everyone watching. So that's kind of interesting. It's that's a way of handling XOR. But look, I mean, we've got cool. The reason we came up with this whole concept for cool is because we were using it here and here because we found that there was a weird and nice and then another weird and nice. But now we're only using it once. We don't really need a variable for that. We can just put cool right in there. And will that work? Yeah, it'll work. No problem. Okay, so that's not bad. That's pretty cool. All right, well, there's just one more thing I want to do here. Someone made a pretty good observation. The only situation, I just noticed something. Okay, I gotta make that a 2. Let's make that a 3 for now. We gotta make sure this actually worked because it was running that before. Yeah, okay, it's actually working. All right, great. Yeah, and I guess we have the same thing up here, so it shouldn't make a difference. Okay, all right, so all of these individually will work. Now, okay, what was I going to say about this? Yeah, I was going to say that we're talking about XOR, right? So we had that sort of table here. And what we find is that if A and B are equal, if they're the same value, we get a false. You know, if they're both ones, trying to highlight them both. Okay, if they're both ones, we get a 0. If they're both zeros, we get a 0. If they're different, we get a 1. So we just need to make sure they're not the same. So really all we need is this? Well, actually, all we need is this, because otherwise it's going to misinterpret it, and it's going to think we're saying, okay, we've got weird and we've got nice is not equal to loved. Not what we want. We want, is this equal to this? Or specifically, is this not equal to this? And as it turns out, that passes all of the hidden and visible tests. So, okay, cool. Nice. And weird. So, I'd say that's probably good. I mean, we've got 4 different, slightly different versions of this. I think that's probably enough. I actually really like that that last version. I think it's nice. You know, we're only using one variable, we're only using each variable exactly once. So yeah, I think that's pretty cool. Okay, nice job, everyone. Let's